Hello everyone, my name is Musai and today we're going to do this microeconomic question. So this question says, suppose a perfectly competitive industry can produce Roman candles at a constant marginal cost of $10 per unit. Once the industry is monopolized, the marginal cost raised to $12 per unit because $2 per unit must be paid to politicians to ensure that only this firm receives a Roman candle license. Suppose the market demand for Roman candles is given by quantity demanded equal 1000 minus 50p, and the marginal revenue function is given by MR equal 20 minus Q over 25. So what I will do, I will show you how to derive the marginal revenue function from the quantity demanded function before we even go into part A, B, or C. The quantity demanded function was 1000 minus 50p. So if we solve for p, we'll get 50p equals 1000 minus q. So p is equal to 1000 divided by 50 minus q over 50. So p is equal to 20 minus q over 50. Now the marginal revenue function would be the same thing, would have the same intercept as a demand function, but twice the gradient. So the same intercept, which is 20, minus twice the gradient, so it will be 2q over 50. So marginal revenue would be 20 minus q over 25. Now this property of the same intercept and twice the gradient, it always holds for any linear demand function. So because this demand function is linear, this will hold. So now we could go and do part A. Part A says, calculate the perfectly competitive and monopoly output and prices. Under perfect competition, in order to maximize profits, we must set price equal to marginal cost. Now the marginal cost under perfect competition, they said, was $10. So the quantity, if you use a quantity demanded function, was 1000 minus 50p. So instead of p, I will just substitute that for the price of $10. So the quantity demanded, I'll put the little d here to show demanded, and the perfect competition industry would be 1000 minus 500, and so your perfectly competitive output would be 500 units. Let's set your MR equal to your MC. And we know the marginal revenue function is equal to 20 minus Q over 25, and the marginal cost in the case of a monopoly was equal to $12 because it was $10 plus they had to pay the $2 to the politicians, so it's $12. So this is the MR in this case, and this is equal to your marginal cost in this case. If we create these equations and we solve for Q, then we will get the quantity that will maximize profits in a monopoly. So in that case, we'll have 20 minus 12 is equal to Q over 25. So 8 is equal to Q over 25. Therefore Q is equal to 8 times 25, which is equal to 200 units. Then to solve for price, we know that price is equal to 20 minus Q over 50, which we would have calculated before, and this is equal to 20 minus 200 over 50. So in all, you have a price of $16. So under the monopoly, you have an output of 200 and a price of 16. Part B says to calculate the total loss of consumer surplus from monopolization of Roman candle production. And part C says to graph and discuss your results. So instead of doing part B and part C, I think it's best to do part C first, then do part B, because from the graph you can calculate the consumer surplus for the perfect competition and for the monopoly, and then subtract it to see the loss of consumer surplus from monopolization. So this is the graph of the demand curve and the marginal revenue curve. The quantity demanded graph was 1000 minus 50p. When p is equal to 0, Q is equal to 1000. This part here is equal to 1000. And when Q is equal to 0, then P, well, we need to find P. So then we can say 0 is equal to 1000 minus 50p. So 50p is equal to 1000. Therefore, price is equal to 20. So the maximum price can be is $20. And I'll write that somewhere up here. So this point up here is $20. This point down here is 1000. And for the marginal revenue, you could do the same thing, and you would get this point here to be 500, and so on. So now we try to, well, we'll graph the perfectly competitive outcome and the monopoly outcome. So under perfect competition, we saw that the price was $10. Under perfect competition, the price was equal to $10, and under the monopoly, price was equal to $16. So just at a small PC and a small m to show monopoly and perfect competition. Now, the consumer surplus for perfect competition is the area of this entire triangle up here. That's for perfect competition. That's the consumer surplus for perfect competition. Now, the consumer surplus under the monopoly is this small triangle up here. So it's always the area above the price and below the demand curve. That is the area of the consumer surplus. The loss of consumer surplus due to monopolization is the shaded area here. For perfect competition, your consumer surplus under perfect competition would be, so we need to calculate the area of a triangle, right? It's a half, and the length. We know the maximum up here is 20, and we know the price starts at 10. There's this area here, from here to here, and from here to here. 20 minus 10 multiply by 500. So if you calculate this, you should get a total of 2500. That's the consumer surplus under perfect competition. And for a monopoly, your consumer surplus of a monopoly should equal is this area right here that we're trying to calculate. So it's just from 20 to 16 and 0 to 200. So it's a half times 20 minus 16 times 200, and this is equal to 400. Therefore, right at the bottom here, the consumer surplus loss from monopolization of Roman candles is 2500 minus 400, which is equal to 2100. This here is a consumer surplus loss from monopolization. So thank you for watching. If you have any questions, feel free to send me an email. Thank you very much. In my days that me a meditate, so me study for the test, me no procrastinate. Early to school, me no have time for late. Sit down in a exam, am I the great?